compare the y component of the center of mass for the two sets of semicircles shown above. Okay, so let's see. Y component, y is going up, so that makes sense. That's good. Let's choose a good contrast color. Red. And so one of the key ideas here is you can find center of mass of individual components and then combine those components. And you'd have to do kind of a weighted average of combining, but if the components you choose are all the same mass, we're going to assume some uniform mass between these things, then you don't have to worry about the weighting because it'll all be equal. You'll see what I mean. So the center of mass for this semicircle will probably be right around there. Center of mass for this semicircle, I'm going to say is probably right around there, less than half specifically. And so the center of mass combined between these two would be halfway in the middle, so it would probably be right there. Center of mass of this guy, probably up here, pretty high. Center of mass of this guy, pretty low, but since they're symmetrical, it's going to be halfway between the two. Well, I guess this one is halfway between the two, but this is going to be halfway between the top and halfway between the bottom. So we have halfway between here, center mass will be there. This assumes, uniform, etc., etc. And so the center of mass will be y1, I'm going to assume that's case 1, will be less than y2, i.e. lower. So I think that's what they're asking, and that's the answer I'm going to give for that one. Not too bad, pretty intuitive. I'm pretty sure you could get some 6th graders to figure that one out. Okay, not to diminish the value of the problem, and I'm sure there's lots of very bright people that get it wrong. On to the second problem, 24. Identical, so we have two boxes. Identical constant forces are applied to two blocks. Click, clack. One of mass m, one of mass 2m, and we'll assume that 2m is twice mass 1, or twice as much as the first one. Both initially at rest on a frictionless floor. Good, frictionless is important. In order for blocks to end up with identical speeds, you need to, okay, so this is talking about how we get the same speeds. So apply the forces over identical distances. So when you're thinking about, so when you see force and you see distance, your first thought here should be energy. So we work, which is energy, is the integral f dot dr. These are vectors, that's a dot product, but since the force is in the same direction as the motion, the dot product is cosine of 0. Cosine of 0 is 1, and we can just write this as f dr. Force is constant, so we can pull it out. This gives us f dr, which is the same as force times distance. And that's a times, where before it was a dot product. Not to be confusing, just part of life. Though I guess life in general can be pretty confusing as well. So what we're going to do then is when you see force and distance and you're trying to get speed, or whenever you see force and distance, your first thought should kind of be energy. So in this case, we're going to build up the energy using force times distance, and then we're going to relay that as kinetic energy. So this will have a certain amount of energy. I'll just call this E. This will have the same amount of energy. I'm going to call this E because they both have the same force and they both go the same distance, because this is assuming for part A identical distances. And so then we have 1/2. If we want to convert that to kinetic energy equals 1/2 mv squared. This would be 1/2 times 2m times v squared. M doesn't cancel, but the 2's cancel. And then v squared will be whatever energy we had over m. Therefore, v will be square root of e over m. For this one, we'd have 1/2 mv squared, just a single m. And so then v squared will be e. This will all then equal e, e over 2m. Is that right? That feels funny. 2 on the top. Excellent. V equals 2e over m square rooted. So this will be square root of 2 times the square root of e over m. And so this second one is going to be moving square root of 2 times faster. So this is like 1 meters per second. This would be like 1.4 meters per second. And so the bottom one is going to be moving faster over identical distances. You can also look at this on a more intuitive level. Like you can break this up into little parts here, where instead of saying you have a block of 2m, you instead have 2 blocks of m, and each of these has a force F over 2 applied to it. And then we have a force m over here. And you look at these and you're like, okay, it makes sense that if we're pushing twice as hard, which is basically, F compared to F over 2, it makes sense that if we're pushing twice as hard, it's going to be going faster than if we're pushing half as hard. So intuitively, you should be like, okay, this one's probably not correct. So the second one, apply the force to block 2m over twice the distance compared to block m. So we have the same concept here, force to block 2m over twice the distance compared to block m. Okay, so we're going to come back to that one. I think that's the correct one, but I'm going to come back to it because there's some nuance there that I would like to address. And so then for C, we have apply the force over identical time periods. Okay, so when you see time with regards to force, your thoughts should be kinematic equations. Not always, but it's the sort of thing where you only got like a minute to solve this problem. So deep thoughts are not really the order of the day. So force equals mass times acceleration. Force divided by mass equals acceleration. And then if we do our kinematic equations, we're going to say that acceleration is constant, which if force over mass is a constant, then it'll be constant. So I'm going to rewrite that as just A. V equals AT plus V naught. We have an integral involved with respect to t. X equals 1/2 AT squared plus V naught t plus X naught. And my 2's look like A's. Don't let that confuse you. Okay. So from this point, we're concerned with this one, speed. The difference between speed and velocity is one is a vector, one is not. So if we look at the first one here, we have acceleration to be force over 2m, which will equal 1/2 F over m. So the acceleration of this first one will be 1/2 F over m. This one, the acceleration will be F over m. And the acceleration then would be, the acceleration for this would be twice the acceleration for the top one. So if we look at it in terms of v equals AT plus V naught equals 0, start at rest. So the V final would be just acceleration times time. And it says we're over identical time periods. So all that's going to matter is the greater acceleration. So this will have greater acceleration. So if we have the same time period of acceleration, this one will be moving faster, i.e. they will not be moving at the identical speeds. Okay, so we're pretty sure it's not C based on the kinematic equations. So intuitively, how are we going to justify to ourselves that the second one, where if we just double the distance? So we'll go back to our work equals force times distance, as we talked about earlier. So we have over twice the distance compared to block M. So the energy that this will have will be, I'm going to call it 2E, because we have twice the distance. This only has E, so this is going to become 1/2 mv squared. This will be 1/2 mv squared. Solving for V here, we have V squared equals, let's see here, this will be 4E. 4E over m square rooted. This one, V squared, will be 2E over m. Oh, I guess I can get rid of this, put the square root. I could just solve for V squared as well. That would give me the same idea. I left out a key component here, the 2m. So this is 2m. That cancels with that. So we have a 2 down here. That'll cancel. And this will give us a final velocity of square root of 2e over m. So this is the same as that. And so this is saying that if we have force applied to 2m and we have a force applied to a single m, it will take twice the distance for them to come up to the same speed. So if we use this, I'm not quite sure how to read this question, so apply the force to block 2m over twice the distance compared to block m. If I just cross out this over and just say that's superfluous. Apply the force to block 2m during twice the distance compared to block m. So this twice here just means exactly twice. Then yes, this is totally the correct answer. If for some reason this over means greater than twice, then that's totally wrong because it's exactly twice the distance that matters. So I'm pretty sure that's just a funny way an unfortunate way of phrasing the question, and then the answer here is going to be B. So that's how we address these problems, is go through each possibility, eliminate the ones that are silly, and then go with the best answer, which is sometimes silly, but maybe less silly than the others. So I hope that helped. I will see you next time.